Hey, this is DW. Welcome to Monday morning. This is the lecture that you will be watching instead of me coming to class because I'm in Chicago at the Parts Cleaning Conference that's associated with the International Machine Technology Show. So I'll bring some pictures to you when we get back together on Friday, but I'm sure I'm having a great time. Anyway, if you're watching this early, good for you. Get ahead of me and ALEKS and get ahead on the homework so that uh, when things get more difficult, you'll have a little bit more time to work on those difficult problems. Okay, let me get my computer squared away so that I can start working on the PowerPoint. Okay, so let's go. All right, so we're going to be still working on topics in chapter 02B, the module B on ALEKS. That's due Monday night. So if you're watching this on Monday, that's due tonight. We'll finish out those topics, and then we'll start working on the ones that are due on Wednesday so that you guys can get ahead of the game. Okay, so today's topics. Here we are on Monday, 9/9. So we're doing these last four topics in ALEKS, where we have, again, deducing the binary compounds from empirical formulas and so on, and working our way up to polyatomic ions. Okay, so let's look at this. Sometimes we have chemical formulas given, and we need to be able to break those formulas into ions. Typically, we need to do this mentally just so that we know how to name things. And so the first one's done for us. That's pretty easy. We have sodium chloride as the compound, and then you see sodium ions and chlorine ions or chloride ions. What about cobalt iodide? Well, it's going to be the cobalt 2 plus and the I minus. Now, already we need to think about this one because cobalt, you may not know that it's 2 plus. But if you look at iodine, it's in column 7, group 7A. It's one away from the noble gas. Everything in that column, like chloride, iodide, fluoride, they all form a -1 anion. And if I know that iodine's -1 and I've got two of them, so if I'm looking at this problem and I'm over here and I've got see, where's my pen not working? So let's see, I'm not sure how to move this around and then I can get to what I'm looking for. Okay, so this might work. Yeah, so if my iodine is a minus right here and I've got two of those, then I know this has to be 2 plus because the whole thing has to be 0. So in breaking these into ions, in order to get the metal charge, a lot of times you have to know something about the anion. Same with sulfur and gold. So here I know that sulfur is in the oxygen group, okay? So that's the group 6A. So I know it's going to be a 2 minus. It wants 8 electrons. It only has 6. So if you look at the periodic table, if it goes 2 columns to the right, it'll be in the noble gas column. So it gets 2 electrons typically and forms a 2 minus. So if the sulfur is 2 minus and the whole thing is neutral, then there's 2 gold atoms. Each one of those has to be a +1. So then the ion formed there is gold plus and sulfide 2 minus. Okay, then we get down to the bromide. Let me shrink this down since I'm recording. Okay, we get to the bromide and similar situation. Bromine is in column 7A, so it's a -1. There's 2 of them, so this should be a Mn2 plus. So that's what I would type in there, manganese 2 plus and a bromide. And then the same for chloride, iron chloride, that's iron 2 chloride. It's a 2 plus iron because there's 2 chlorides. So these look easy, but they're a little bit more tricky than you'd imagine because you've got to take something that you know to figure out the thing that you don't know. And in all of these cases, except for sulfur, all of these were -1s because they were in group 7A. Sulfur is in group 6A, so it's a -2. Okay, what if we're given the name and we need to go to the formula? Okay, so we have iron 3 iodide. So we know this gives us an iron 3 plus, and that means we need 3 iodides because each one of those is a -1. So that's what I'm talking about. We've got a 3 plus. Each one of these is a -1. And so I'm going to need 3 iodides. So FeI3. Rubidium fluoride. Well, I know that the fluoride is a -1. So I need to go to the periodic table to find rubidium. So if I find rubidium, it's right below potassium. I've got a periodic table on my desk. So rubidium is in group 1A. So it's going to form a +1. So those match. So it's just RBF. Strontium sulfide. I look at strontium. It's in group 2A. So that's a 2+ ion. Sulfide is in group 6A. And so that's going to be a 2-. And so those match. So I just have SRS. Okay, this is not a common chromium. Common chromium is chromium 3 or chromium 6, but this is chromium 2. So that means it's a 2+ because of the 2. And then the bromine is a -1, or bromide is a -1. So I need 2 of these -1s. I need this whole thing to be doubled. And so it'll be CrBr2. And then if I have a 10-4, this is a 4+, Br-. Okay, so I need 4 bromides. And then sodium sulfide. Sodium is in group 1A. So it's a +1. And the sulfide is a -2 because it's in group 6A. And so this time I need 2 of the sodiums. So I need the sodium to be times 2. So it'll be Na2S. So there's, a fair bit of science in the names. We got to know what groups they're in, so what ions that they form. And this is a good practice. So I would say practice going forwards and backwards. Start with the molecular formula or empirical formula and learn how to name it, and then start with the names and learn how to make the formulas. Now this is taking element names, and making ionic compounds with them. And again, we got to know what the common ions are going to be. Like oxygen is going to form a 2- oxide anion. And so in this case, they don't want us making the molecular compounds. They just want us making the ionic compounds. So the first task is to look to see if we have a metal and a non-metal. So I would say this is metal plus non-metal. That's the question we're asking. So potassium's a metal, oxygen's a non-metal. So sure enough, the first one is yes. Oxygen's a non-metal, iodine's a non-metal. So the answer is no. Oh, and here's the formula for that one. So the oxygen is going to form an oxide. So 6A. So it's going to form a 2-. Potassium is in group 1A. So that's going to form a 1+. So I'm going to need 2 of these. So potassium, K2O, so potassium oxide. Now the oxygen and iodine, both of those are nonmetals. So we're going to say no on that. It doesn't form an ionic compound. And so then there's no empirical formula to write. So I would leave that blank. Sodium and chlorine. So yes, sodium's a metal, chlorine's a nonmetal. This is group 1A for the sodium. That's on the periodic table. That's the column it's in, group 1A. And so then it's a 1+. And chlorine is in 7A. It's 1 away from the noble gas. So that means it's a 1-. So they match. So it's just NaCl. That's why there's no subscripts on sodium chloride, because they match, +1 and -1. Magnesium's a metal, oxygen's a non-metal. And so then we say yes on that. It forms an ionic compound. And these match too, because magnesium is in group 2A on the periodic table. So that means it's going to be a 2+ cation. Oxygen is in 6A, so that means it's going to be a 2- anion. 2 plus, 2 minus, so we don't need any subscripts. It's just MgO as magnesium oxide. Let's do it again. This is good. So again, our forms ionic compounds, that's answering the question, is it a metal plus a non-metal? Cesium is a metal, and barium is a metal. So we have to say no on that one, and there's no formula to write. Potassium is a metal, chlorine is a non-metal. So yes, and potassium is in group 1A. Chlorine is in group 7A. Okay, so that group 1A means it's a +1. And group 7A means it's a -1, plus one negative charge. So it'll be KCl. Cesium and bromine. Okay, same thing. Cesium is right below rubidium, it's in period 6. So it's in group 1A. And bromine is in 7A. Metal, non-metal, yes. And so it's just going to be CSBr. And then we have calcium and bromine. So calcium is in group 2A, which means it's a +2 charge. 2 positive charges, bromine is negative. So we're going to need 2 bromines to make bromide, 2 bromides. So that's calcium bromide. So this is going from the elemental names. So now you can look at the periodic table and you can make a whole lot of compounds that exist in nature. Just knowing how the chemistry of the different columns reacts, you know the subscripts and superscripts, well, the subscripts of the different molecular formulas. Okay, then we get into, so we've used a lot of these common cations. These are all the, the group 1A ones that we've been using. Actually, hydrogen is in group 1A as well. It's just not a metal. Group 1A. So they all form positive cations. Silver is a transition metal, but it also forms a +1 cation. Then group 2A, so this goes down to barium all the way here. So magnesium, calcium, strontium, and barium. On the periodic table, those are group 2A. Zinc and cadmium are transition metals that form +2 ions. And then aluminum forms a +3 because it's in group 3A. Okay. But it's really the only one that forms a 3+ ion because of what group it's in. All the others are metalloids, but it's a metal that gives up 3 electrons. Then we have all of these transition metals, and it gets a bit confusing. I showed you last time on, I guess, Friday's lecture, the periodic table, and showed you all of the common cations, the copper 2+ and 1+. So here's copper here. It forms both of these, and so that means we have to put that Roman numeral. See, none of these have Roman numerals. None of these have Roman numerals. Okay. But when we get into here, this side of this chart all requires these Roman numerals, except for the ammonium ion. Ammonium ion is on this chart because it's a polyatomic. So see all the different atoms in there. We would call that polyatomic cation. There's another polyatomic cation down here, that mercury one that I was talking about. So we really only have 2 of those. We have ammonium here and mercury here. And sometimes we'll see hydronium, so H3O+. Okay. Hydro, because it's water. Hydronium. Okay. So that's another polyatomic cation. So there's 3 really common ones like that are cations. There's a whole bunch of polyatomic anions. You can see the iron 2 here and iron 3, so those are coupled. Well, I mean, just that they're both iron. And so we need to know that Roman numeral to know which iron we're talking about. Manganese, mercury 1, mercury 2, nickel, etc. All of these different cations. These are the really common ones. So I'd say you just really need to memorize these because they're so common. You'll see them all the time, and especially in your problems and on the exam. Okay, let's look at the anions. It gets a lot more complicated when it comes to the anions because you can't always use the periodic table. You can use the periodic table for group 7A. So over here, these are group 7A. And sometimes hydrogen is moved over there and put in group 7A because it also forms an H-. But this is group 7A. Group 8A is the noble gases. And so this is 1 away. So if these get an electron, they have the same electron cloud. They're isoelectronic with the noble gases. Then group 6A, oxygen and sulfur, they form these 2- ions. And this is a polyatomic anion called the peroxide ion. You've heard of hydrogen peroxide. If we put 2 hydrogens on here, we make hydrogen peroxide. Okay. And then the nitride ion is down here, the N3-. So that's group 5A. So those are the only ones that you can figure out just by their position on the periodic table. The others just absolutely have to be memorized, like cyanide ion, Cn-, and hydroxide ion, OH-, and acetate. Okay, it's written 2 different ways. I've seen them both. I like this one best here because it kind of shows the structure of the molecule. The molecule actually looks like this. Let me just draw it in a simplified form. An H, C, H, H. So that is the CH3. Then we have a C, and it's got a double bond with an oxygen, and then a single bond to this oxygen that's bonded to either it's a minus, which makes it the anion, or it's bonded to a hydrogen. But if we take off that hydrogen, then we have the acetate anion. So you see why it's written CH3. So this is the CH3 part. COO minus. So if we got rid of that hydrogen and we left the electron behind, it'd be a negative charge on that oxygen right there. And so it'd be CH3 COO minus. So that's what's being done right here with the acetate anion. But sometimes we teach you how to clean up your structures, and so you would combine the carbons and combine the oxygens, and you'd have C2H3O2 minus. So be on the lookout for both of those. They're both acetate. There's 2 different ways to write that. Then we have chlorate and perchlorate and nitrate and permanganate. All of these 8s. These 8s are very common. These are the oxy anions. They have oxygen in them. Here's carbonate and chromate and dichromate. You see, it's kind of like 2 chromates. That's why it's dichromate. And the sulfate and the phosphate. So all of these 8 anions are called oxo anions or oxy anions because they have oxygen bonded in there, either with a nonmetal or a metal. Really no way around memorizing these. So let's talk some about these 8s. 8s are the most common forms of the oxy anions. So you can see that perchlorate uses chlorine, which is in group 7A. Sulfate uses sulfur, which is in group 6A. And you see the charges increase right to left. So Group 7A, ClO4 is a -1. The sulfate is a -2. The phosphate and nitrate are in group 5A, and they have phosphate has a -3, so that's on period 3. So these increase 1, 2, 3, going from right to left. The nitrate is a -1, and then the carbonate is to the left of that, so it has a -2. It's just trying to help you understand or memorize the charges on these oxoanions. Okay, and the one on period 2, the carbonate and nitrate, they max out at 3 oxygens. On period 3, they max out at 4 oxygens. Okay. Now, there's lots of other versions of this. Let's just take this perchlorate one. There's a chlorate, and there's a perchlorate. Notice the chlorate is the most common form. And I'll call this the base model, right? Okay. It's kind of like you go into you buy a car, you buy the base model. It's got all the features, but not all the fanciest features. The perchlorate has one more oxygen in it. So it's plus. It's perchlorate. And it's been upcharged a little bit. It's got leather seats, okay? The chlorite, okay, has one less oxygen. Notice how it went from chlorate to chlorite, and it's ClO2, not ClO3. That one, you're saving a little money. Maybe you have a bench seat instead of a console in the middle. It's not as much oxygen as the chlorate. And then the hypo means less or under, okay? So hypochlorite means even further less. This one's the stripped down model, the bare minimum. So hypochlorite has the smallest number of oxygens. So we have chlorate, then we lose an oxygen, we end up with chlorite. We lose another oxygen, we have hypochlorite, so even less than chlorite. Or if we start at chlorate and we want more, we have perchlorate, so we have even more oxygen. So it goes from ClO3 to ClO4. This same kind of thing works with sulfate. We would have sulfite, would be SO3. And phosphate, we would have phosphate, which would be PO3. What about nitrate? Well, we do have nitrite, and it would be NO2. See, it would just be one less oxygen than nitrate. So the trend works. Okay, the same scheme applies to the other oxoanions relative to the 8. So this NO2 minus is nitrite because it's one oxygen less than nitrate. And then we have some of these that you can put hydrogens on, like phosphate can go up all the way to 3 hydrogens. And so then you could have phosphoric acid if it has all 3 hydrogens on it. But if you lose one of those hydrogens, let's say you have H2PO4, then that's called the dihydrogen phosphate ion. So they're kind of bringing in a little bit of those binary covalent rules in here in the naming. Don't let that confuse you. This is still an ionic substance, but how else to describe it? You want to say 2 hydrogens, and so dihydrogen would be the way to say that. And then this other one would be that if you just had one, it would be the hydrogen phosphate ion. H. Let's write that out. You don't have to write mono on the first one. You just say hydrogen phosphate. Just like this one over here is the hydrogen carbonate ion. Okay. So let's make some common ionic compounds with polyatomic ions. So here we did these problems on Friday, but we just had the bromide and fluoride. Now we've got polyatomic ions. So we still are trying to make neutral compounds with these. So we have the magnesium with the 2+, the hydroxide with the 1-. And so we're going to need 2 of those hydroxides. And here we have a magnesium 2 plus, and here we have, which one is this? This would be the bromate. If chlorate is ClO3, then this is bromine. BrO3 would be bromate. Okay, we'll name these later, but since we're here, I'll go ahead and write it out. This is bromate. Kind of funny. Bro and mate, kind of like a combination of bruh and then the Aussie, the Australians call everybody mate. So anyway, that's magnesium bromate, MgBrO3, 2. We need 2 of those whole units. So look where we put the parentheses. Put it around the whole thing. You can't just leave the parentheses out. If you put a 2 there, it'll look like oxygen 32, and that's not right. Okay, now we've got a cation with 4 charges. So nickel, OH only has -1, so we need 4 of those. We put the parentheses and put a 4 down there, and the same with the bromate. We put a 4 down in the corner, so that we need 4 bromate anions for 1 nickel 4 plus cation. It's pretty straightforward. Okay, let's do some more. Okay, now we have iron and sulfate. Both of those match. So iron's 2 plus, sulfate's 2 minus, so it's just FeSO4. We need parentheses for okay, this one is going to be permanganate. So kind of like the chlorate went to perchlorate when it had 4 oxygens. Here's manganese when it has 4 oxygens. That's permanganate. Okay, so it's only -1 for that, so we need 2 of those in parentheses. Then we have the ammonium cation. And so we're going to need parentheses for that on the sulfate, because the sulfate's a -2, the ammonium cation is a +1, so we need 2 of those cations. And then they match with the permanganate, so you can have ammonium permanganate. And if you don't know your cations and anions, and you look at this, you're not going to know where to break this compound into its ions. If you know that this is a cation here, and this is the anion here, then it totally makes sense that this would break apart, and this would be the ammonium cation and the permanganate anion. You put this in water, it's going to break apart, it's going to form those ions. But if you didn't memorize your cations and anions, and you look at this compound, how do you know that it's not like breaking here and making an N3 minus, or like breaking here and making an Mn2 plus, right? So if you've just, there's no substitution for memorizing the polyatomic ions. There's only 10 or 12 of them, so it's not that big of a deal. And you'll know a lot about chemistry. Okay, so that's everything that's due tonight, Monday night. So let's go ahead and look towards Wednesday. So when we get to Wednesday, here's the topics. We're going to be looking again, practicing some more with naming those binary compounds, and then we'll be predicting naming the ionic compounds formed by 2 elements, and then identifying the common polyatomic ions. So let's practice again with the molecular compounds, these covalent compounds made of the nonmetals. So now we have dibromine monoxide. So we've got to know, again, this dibromine, that's going to be Br2, and then monoxide is going to be a single oxygen, so Br2O. Then we have boron monophosphide. So again, the phosphide, that's P, so BP. And then the silicon dioxide, silicon is Si, and we need 2 oxygens, so SiO2. And the same kind of thing for sulfur dioxide. Sulfur is S on the periodic table, and we have 2 oxygens, so it'd be SO2. Pretty straightforward. Notice we don't have to put charges on here because these are not ionic compounds. Now we might be able to say that there's if you tried to force it to be charged and so on, that would be called formal charge, and we'll talk about that later. But no, these are not charged. These are not ionic compounds. These are sharing electrons roughly equally, so we call them covalent molecules. Okay, so let's look at some more of these. Now we're starting with the formula, and we're having to give the name. So here we're looking at the periodic table, and we see xenon, and then this is fluorine, so it'll be xenon, and then this is 6, so it's hexafluoride. Okay, so xenon hexafluoride. Here we have 4 seleniums and 4 sulfurs, so it's going to be tetraselenium tetrasulfide. So tetra being 4, so tetraselenium tetrasulfide. Here's selenium disulfide. So there's just a single selenium. You don't have to put mono on the first one. So it's just going to be selenium disulfide. Back to xenon. Now we have 3 oxygens. So that's going to be trioxide. So xenon trioxide. And then you could say this is dihydrogen monoxide, but that's water. So if we do CH2O, just that's the name of it. It's water. Okay. So hopefully these are easy and you can crank through them on ALEKS. All right, so now we have the option of not just forming ionic compounds, but we can form no, this is very similar to the problem we already did. If it forms an ionic compound, then we give the formula and then we give the name. So we just added the names to it. So again, if this question here, does it form an ionic compound? Is it a metal plus a non-metal? So chlorine's a non-metal, magnesium's a metal, so yes, that is a metal and a non-metal. Okay. And so the magnesium is in group 2A. So that's going to be a 2 plus. Chlorine is in group 7A. So that's going to be a 1 minus. So I need 2 of the chlorines. So MgCl2. Magnesium's in group 2A, so it's always a cation of 2 plus. So we don't need a Roman numeral. So we'll just call it magnesium chloride. Okay, so the next one, sodium is a metal, sulfur is a non-metal, so yes, that will form an ionic compound. Sodium is in group 1A, so that means it's a 1 plus charge. Sulfur is in group 6A, so that means it's going to be a 2 minus. So I need 2 sodiums, so it's going to be Na2S. And since sodium is in group 1A, we don't need any Roman numerals because it's always going to be a +1. So that's just going to be sodium sulfide. Then we get into sodium and strontium. So this is going to be a +1, and this is going to be a 2 plus metal cation. So those aren't going to form an ionic compound because they're both going to form positive cations. There's no anion to react with. So we're going to say no on that one. And so there's nothing to put down in terms of the name or formula because these guys don't react with each other to form a compound. Okay. And then we have sulfur and magnesium. Sulfur is a non-metal, magnesium is a metal. So sure enough, we have an ionic compound. We can see that sulfur is in group 6A, forms a 2 minus. Magnesium is in group 2A, forms a 2 plus. So 2 plus and 2 minus, they balance out. So it's just MgS. And magnesium's in group 2A, so we don't need a Roman numeral. So it's just going to be magnesium sulfide. So this is pretty straightforward. Lots of things to do on this particular ALEKS problem. Okay, so then this one is just a brute force, test your memory of the polyatomic ion names. And you can beat your head against ALEKS and test your knowledge, and that's great, but you may want to take a little sidestep. I mean, we can go through these and name them. That's the carbonate anion, that's the bromate anion, that's the hydronium cation, and the permanganate anion. And you can work on ALEKS, but you might want to do this in terms of memorizing. I've got a Quizlet class that you can go to. This is the polyatomic ion flashcard set. So if you study this set, it gives you these flashcards that you can use, and you can like test your knowledge. And so this is a quick way to, you can do Quizlet note card sets on your phone, you can do them on your tablet, you can do them on your PC. So I recommend, if you have trouble with memorization, this is the way to do it. It's just brute force recognition. When you see these elements and subscripts and the -1 all together in that form, you know that's acetate. And so there's just no way but to memorize that association. Acetate, when you see that word, this is the formula you think of. So you got to go forwards and backwards. If you're given the name, you need to be thinking of the formula. If you're given the formula, you need to be thinking of the name. And then this, you can go back to ALEKS, and then you can fill these out, get 3 in a row, and boom, you're done. Okay, there's other flashcard sets too when we get into the mineral acids and the weak acids and so on. So if you join this classroom here, you may have to set up a free Quizlet account, and that's okay. Just, fill out the form, and then you can join my Quizlet classroom and you can work on these memorization lists of polyatomic ions, acid names, and things like that. We have other things in there too, like the solubility rules. So it's worth it to join this Quizlet class so that you can do some of the memorization work, and it'll make ALEKS go a lot faster. And more importantly, you'll know the vocabulary of chemistry. So when I'm talking about acetate, you don't have to sit here and think, well, now what is that? I've forgotten. So, all right, so that's where we are. Go practice on Quizlet, nail those questions in ALEKS, stay up with us in class, and maybe even get ahead. These are due on Wednesday. I'll see you in the next video for the Wednesday morning lecture. Till then, bye.